today we're going to talk a little bit about average value, and average value of a function over AB is found by 1 over b minus a times the integral from a to b of f of x dx. So we take into consideration how wide the domain is, and we give you that formula right here. How do you find the average? Arithmetically, you would add the numbers. And divide. The sum by the width of the region. So, let's try one. It says find the average value of the function f of x equals 1 plus x squared on the interval from negative 1 to 2. So our f average is going to be equal 1 over 2 minus negative 1. The integral from negative 1 to 2 of 1 plus x squared dx. So, we work this out, we need 1/3 times the antiderivative of our integral from negative 1 to 2, which means 1/3 times 2 plus 1/3 times 8 minus negative 1 minus 1/3 times negative 1 cubed. I'm going to do this all in thirds, so we get 6/3 plus 8/3 plus 3/3 plus 1/3, which gives us 14, 15, 16, 17, 18/3 times 1/3, which is 18 over 9 or 2. So your average value is 2. What's really happening is you are adding the areas of all those rectangles and dividing by the width. You can see what the average rectangle area is. So, mean value theorem for integrals is similar. It says that if f is continuous on a to b, then there exists a number c such that the average value is equal to f of c. Or you can multiply the b minus a over here, and then you have the integral equal to f of c times b minus a. So, here's how this works. It says at some point c, f of c times b minus a will equal the area under the curve. And we're doing an example, the same example we just did. So it says there is a number c. So what they want us to do is take 1 over 2 minus negative 1 times the integral of negative 1 to 2 of 1 plus x squared dx. I think I might have forgot my dx earlier. No, I didn't. Okay. Felt like I did. 1 plus x squared dx, and that has to equal f of c. Well, we don't know that value. That's what we're solving for. So we put c in our equation. Now, we already found out from our earlier problem that this is equal to 2. So if 2 equals 1 plus c squared, if you want to solve this, 1, subtract 1 from both sides, so 1 will equal c squared. So c has to be plus or minus 1. Now, let's see how that goes. So, our function, 1 plus x squared, sketch this, looks like this. And what we mean by this when f of c is 2 means that at negative 1, the value is 2. At 1, it's 2. And they're saying that we were talking about the area between negative 1 and 2, which is that big, I'll highlight it, this big area. And when we found the average value, and we found it to be 2 at those points, that means that this rectangle, as outlined in green, has the same area as what we shaded in yellow. So, this rectangle outlined in green, which I could highlight another color, has the same area as what was shaded in yellow. Some of that's disappeared now, but that's the general idea of average value of a form of a function and the mean value theorem for integrals. If you have questions, bring them to class tomorrow and we'll see what we can do.